Yeah, I see Bumbling Bamboo Tree said hi, so that's how you use the chat. Hello.
So exciting.
Sure, go ahead. Cool, thanks, Michelle. Yeah, that's really cool. And Maggie is also involved with Integirls. She's actually a Integirls, she's the Integirals chapter head of Missouri. Apart from that, she's also super accomplished in math competitions. She's qualified for Amy twice. And a fun fact about her is that she has played tennis for 10 years, which is a very long time.
Yeah, and actually Audrey is very good at math as well. She's a USAMO qualifier, has represented Nevada at Math Counts Nationals, and also has played viola for 8 years, so also a pretty long time. Okay, awesome. Do you want to get started then, Audrey? You can go first.
Sure. Okay. So here are the problems.
A quick disclaimer before we start. So Audrey has never seen the problems, and I am also a chapter head, but chapter heads are in charge of writing the problems. So I haven't I don't completely remember or see the problems. So yeah.
Yep, they're all new to us. Also, I'm sorry in advance if the wind is carrying through because it's very windy right now. Okay, so I guess the first question we have today is individual number 3. Oh, that's interesting. Michelle is featured in the problem. Yolanda and Michelle are evaluating 3 plus 5 times 4. Nice. If Yolanda forgot to follow order of operations and just evaluates the expression left to right, what was the absolute difference between Yolanda and Michelle's answers? Okay, so this one seems pretty straightforward. I'm just going to find what Yolanda's answer was and what Michelle's answer was. So let's see. Yeah, Michelle was just the one who did it correctly. In this case, order of operations just means that we want to perform the multiplication before we perform the addition. So Michelle would have done 3 plus 5 times 4. Well, that equals 3 plus 20, which is 23. On the other hand, Yolanda, she just went left to right. So that'll be different from Michelle's answer because in this case, she'll add first. So she gets that 3 plus 5 times 4 equals, I'm going to put a question mark here because it's not true, equals 8 times 4, because she just did the addition here, and that equals 32. And so they're asking for, sorry, I'm a bit off screen. They're asking for the absolute difference between Yolanda and Michelle's answer. So I will just get that by doing 32 minus 23. And that equals 9. Let's see, is it 9? Yes, it is 9. Cool.
Yay. That was good. Also, don't be afraid to put anything you want in chat relay, like ideas or anything else. Okay, on to the next problem. So this is Integrals Middle School Individual number 4. Friends Natalie, Olivia, and Erica are eating pie. Natalie eats 1/2 of the whole pie, and Olivia eats 1/3 of the whole pie. if the amount left for Erica can be expressed as A over B for relatively prime A and B, what is A plus B? Okay, so this is fun. So we have 2 pies, or no, we have 1 pie, and then Natalie eats 1/2 of it, and then Olivia eats 1/3 of it. So this can be 1/2, and then this can be the part that Olivia eats. And then so the remaining part is what we want to find, which is the amount left for Erica. So we can also put this in fraction form. So 1 minus 1/2, which is what Natalie eats, and then minus 1/3, which is what Olivia eats. So we can calculate this. I'm going to take this part and then like 1 minus 1/2, because I already know that's 1/2. So I'll just do 1/2 minus 1/3. So if we do the fraction, we will, or common denominator, we will get 3/6 minus 2/6, which is 1/6. And so those two are relatively prime. So A and B are 1 and 6. So this is 1, 6. So it's asking for A plus B. So 1 plus 6 equals 7. Okay, hopefully that's right.
Yep, it's 7. Great. And I see that Max also got it in the
Yay.
chat, which is great too. Generally for this one, like my only comment, I think Maggie did it great in a great way. But my only comment is kind of common for contests to ask for a fraction, and then they ask for A plus B, where the fraction is A over B. So just one thing to keep in mind is make sure you don't actually put in A over B. Just answer what the question is asking for. Okay, moving on to individual number 5. Senor, I don't speak Spanish, Aft, is playing on his calculator. However, his calculator is unable to display decimals. Okay, so just like integers. If he inputs square root of 6 pi, what integer shows on his calculator? Okay, so this one, it's basically like an estimation problem. So we want to find what the square root of 6 pi is. Basically just to the nearest integer, which is nice because we don't have to calculate past 1 decimal point. And you guys might know that there are like a lot of different approximations for pi. Some of them are more accurate than others, but honestly for here, I'm just going to use pi is around 3.1. And I can be fairly confident that that'll work and give me the right answer because we only want to find it to the nearest integer. And so pi is pretty close to 3.1. So plugging that into this expression gives the square root of 6 times 3.1, which is the square root of 18.6. And this is a step where I would have to estimate again. So clearly I don't know the square root of 18.6 off the top of my head, but I do know that the square root of 16 equals 4. And I also know that the square root of 25 equals 5. And so the square root of 18.6 is somewhere in between 4 and 5. And in this case, like all we have to do is figure out whether it's closer to 4 or 5. And I'm going to say that it's closer to 4 because 18.6 is a lot closer to 16 than it is to 25. There's like just a difference of about 2.6. For senior Aft. Yeah, I would not want a calculator like that. Let's see. Yep, okay, so the answer is 4.
Yay. Okay, on to the next one. Beaver siblings Winnie and Lucille are looking to build a new house and need more logs. If Winnie brings back 3 logs at the end of every 2 minutes, and Lucille brings back 4 logs at the end of every 3 minutes, how many minutes will it take to collect 88 logs? Oh, this is fun. Okay, so it looks like they both bring at different rates. So the first thing I would think is to maybe see if they have a common thing for like 6 minutes, because then every 6 minutes they would bring like a certain amount of logs. So Winnie brings back 3 logs at the end of 2 minutes. Oh, and I picked 6 because 2 and 3, they're like common, or no, greatest common factor, 6. So if Winnie brings back 3 logs at the end of every 3 minutes, I'll put W for Winnie. 3 logs, 2 minutes. In 6 minutes, it would be times 3, so it would be 9 logs in 6 minutes. Yes, least common multiple. Okay, yes, that's true. And then, okay, and then Lucille brings 4 logs every 3 minutes. So in 6 minutes, Lucille would bring, so 3 times 2 is 6, so it's 8 logs here. So at the end of 6 minutes, both of them bring a total of 17 logs. And even though they bring them back at different rates, because the minutes, they have the least common multiple, like Max said, then the number of logs would stay the same, like in that time frame. So we want to collect 88 logs. So we can see how many times they have to bring 17 logs in. So 88, I'll just do divided by 17. And 17 is around 20 and 88 is like kind of around 90. So I would guess like 5 here. So we'll see what this equals. 85. Okay, nice. So you need 5 of 17 logs, and then you have 3 logs left. Let's just do this. So 88 divided by 17 is 5 with the remainder of 3. So that means after 6 minutes has passed 5 times, then there's 3 logs left to bring. So let's write that down actually. So 6 times 5, 6 minutes times 5 equals 30 minutes. So after the end of 30 minutes, they have 85 logs. So they need 3 more logs. So we can just look back at the problem. So Winnie brings back 3 logs at the end of every 2 minutes, and Lucille brings back 4 logs at the end of every 3 minutes. So that means in the next 2 minutes, Winnie will bring back 3 logs. And then they'll have 88 logs because we just need 3 more from this. So 30 plus Winnie's time, which is 2 minutes. And the answer should be 32 minutes.
Yep, it is 32. That's actually, it's a pretty interesting problem. It reminds me of the ones where it's like a frog is jumping up the side of a well, it jumps up 5 feet and then it slides down 2, and then it jumps up 5 feet again and slides down 2 again.
Mm-hmm.
And you're trying to figure out like how much time it takes the frog to get to the end of the well. And I think the tricky part about both problems, although like this beaver one's definitely more complicated, is thinking about the end, because yeah, you just have to, for the frog example, like at some point it'll jump up 5 and then it'll already be at the end. So clearly it won't slide down. And then in this case, like, yeah, you just have to pay attention to the end. I think I do like the way Maggie did it, where she combined Winnie and Lucille's rates into something per 6 minutes, because generally dealing with fractions is kind of messy. But I just wanted to note that you could also find Winnie and Lucille's combined rate by just doing 3/2 plus 4/3, because Winnie does 3 logs in 2 minutes and Lucille brings 4 logs in 3 minutes. So this would be in logs per minute as well. And then from there, basically like do the same thing as Maggie. I believe you end up getting like around 31 point something. So in that case, you would have to consider Winnie bringing back the extra 2 logs. Okay.
Yes, but you would also have to pay attention to the end, probably, like
yeah,
yeah,
for sure.
That's a good way of solving it too, I think.
Oh yeah, and just a reminder before we move on, whether or not you guys actually like did these problems during the tournament, feel free to send in like what answers you got, or just ideas for how to get answers into chat. That makes these live solves a lot more fun. Okay, so now, we're on to relay. Cool. So cities A, B, C, D, and E are all located on a straight line. City A and City B are 120 miles apart. City B and City C are 75 miles apart. Okay, I guess I'll like start writing down. A to B is 120, and B to C is 75. And cities C and City D are located 67 miles apart. Cities D and cities E are located 4 miles apart. Okay, and what is the least possible distance between City A and City E? So basically we're trying to minimize the distance between A and E. Okay, honestly, with these kinds of problems, I sort of try to use the information. Yeah, like as Max says, draw it out on a line. That's definitely a good first step. We want to be able, it's not a very straight line, whatever. we want to be able to visualize this. So actually here, we know that A and B are 120 apart, which is the biggest in the set of lengths. So I'm just going to draw them first, and we'll say that this has a length of 120. Okay, and here's where it gets a little more complicated because there's definitely multiple ways. Let's see, B and C are 75 miles apart. So that means C could either be here or around here, where each thing is 75. C and D are 67 apart, and D and E are 4 apart. Wait, actually, this kind of, okay, so it seems like I guess a geometry problem, but I think it's more of a number theory problem in disguise. Because if you think about it, to get from A to E, first we're going from A to B, then from B to C, then from C to D, then from D to E. And taking each, like, for example, B to C, we could either go 75 to the right, or we could go 75 to the left. So essentially, let's assume like from A to B, we're going plus 120. So here we're assuming that B is to the right of A, which is, it's possible because like either way, it's not gonna matter. But here from B to C, we'll either subtract or add 75. If we add 75, we're assuming that C is over here. Oh, ooh, something happened.
Yeah, I think
Uh-oh.
the display might not be working.
Yeah. Well,
But it
while
will be
that's getting
fixed soon.
fixed,
No
Yep.
worries.
Yeah, I like this problem a lot because
Yeah,
it's definitely.
I almost thought you would have to just add everything, and then I didn't catch the least possible distance part.
Yeah, that was my thought. Oh, cool, we're back. Yeah, so my thought process first was also to kind of like think about the possibilities and see which one intuitively makes more sense. But it seems like there's more of a slicker way to solve it. So anyways, we go from A to B as plus 120. From B to C, if we add 75, we're assuming that C is over here. But also C could be over here. So that would mean subtracting 75. And similarly, to get from C to D, we would either subtract or add 67, depending on whether C is to the left of D or whether D is to the left of C. And again, like I'm trying to minimize the difference between A and E. So I just want to make this expression, oh, I'm writing over the problem. 120 plus or minus 75 plus or minus 67 plus or minus 4. I want to make this as close to 0 as possible. That'll be the same thing as minimizing the distance from A to E. And to do that, okay, I'm definitely gonna put 75 and 67 together. So they're definitely gonna have the same sign, because if they have an opposite sign, this 120 is super big compared to 75 minus 67, which is 8, and the other 4. So with 120, 8, and 4, we really can't do that much. However, if I add 75 and 67 together, that gives, let me not mess up on this, 142. And that's it's pretty close to 120. So at least it can kind of cancel it out. So I'm thinking that we should do 120 minus 75 minus 67. So that's going to give us negative 22. And then I want it to be close to 0. So I'm going to add 4 instead of subtract 4. And that gives negative 18. And it's definitely a number that's closer to 0 than if we had taken like 120 minus 75 plus 67 or something like that. So that's how I arrived at negative 18. And then finally, like distances are always positive. So the answer is not negative 18, it should be 18.
Yeah, and it looks like it is correct up
Cool.
here. Yay. And okay, the next problem is a team problem. But that was a good problem though, I think. Very hidden.
Yeah, it's pretty cool.
Yeah. Okay, so for team number 3, Wallace the otter is juggling 100 rocks. After the first minute, his sister Wanda knocks 1 rock out of his paws. Every subsequent minute, Wanda knocks out 1 more rock than the previous minute. Example, After the 3rd minute, Wanda knocks 3 rocks at a wall. Wallace has paused. How many rocks will Wallace have after 7 minutes? Okay, this is a fun problem. So it looks like Wallace starts with 100 and he's juggling them, which is an important fact. Okay, 100 rocks. And after the 1st minute, Wanda will knock out 1 rock. And then after the 2nd minute, 2 rocks. So it keeps on going until, yeah, and Max, I think, is saying the right. So this is a general formula for like X minutes or N minutes. So that's a good 100 minus 1 minus 2 minus 3 all the way to N. Yeah, so it's really good. All the way to 7. Okay, so it looks like we can just do this manually. But then also a trick that I want to point out is consecutive sum. So if you have 1 plus 2 plus 3 plus, and you keep going all the way to N, there's actually a formula for this, which is N times N plus 1 over 2. And this is from, I think it was it Fermat, Audrey? I'm not sure which mathematician.
I don't remember. I know there's like Gauss. There was that story about Gauss who his teacher told him to do like 1 plus 2 plus all the way to 100 just because she was lazy and wanted to occupy his time. And then he figured out the formula in like 2 seconds. Yeah, I'm not sure. Maybe you should Google that.
Yeah, no, I think that's the story I'm thinking about.
Yeah.
So yeah, so the teacher told him to do this, like add all of this up. And so actually you can see there's like a symmetry. So if you add these two, it becomes N plus 1. And then this is over here, the previous term is like N minus 1. If you add 2 and then you add N minus 1, it's not drawing. Okay, if you add 2 and you add N minus 1, it also becomes N plus 1. So you can see that they're like pairs. So if you add that, you take the first and the last like term and you add them all together, they're all the same. So in total there are, oh wait, can you guys hear me? I think I'm like maybe lagging a little bit.
Yeah, we can hear you.
Okay, good. Okay, so in total there are N divided by 2 pairs, because you have N terms and you have N divided by 2 pairs. And also if you have like an odd number of pairs, like 1, 2, 3, you can say there's 3 over 2 pairs. Like the 2 just becomes 1 pair by itself, the middle term, because it's still equal to N plus 1. Anyway, so yeah, you have N over 2 pairs. And then all of the pairs have a sum of N plus 1. So then you multiply those two together and that becomes your general sum. So that's why you have the formula right here, right there. Okay, but anyways, going back to the problem. So we can do 100 minus 1 minus 2 all the way to the answer. Right now I'm just gonna use the formula because I'm lazy. But so 7, 1 plus 2 plus all the way to 7. So that means 7 is N. So then this formula becomes 7 times 7 plus 1 is 8. So 7 times 8 divided by 2, which is equal to 28. Because 8 divided by 2 is 4. So then you multiply by 7 and it becomes 28. So the problem becomes 100 minus 28. And the answer should be, trying this in my head, 72.
Yes, it is 72.
Yay.
I just want to say before moving on that I really like the storylines for these problems. They're great.
Ah, fun problems
Okay.
too.
Oh, so we're back to an individual problem. This is individual number 10. Shirley is building an outdoor playpen for her cats using chicken wire for the perimeter. If she has 36 meters of chicken wire, what is the maximum area she can fence in for them? So this is another problem that asks us to maximize or minimize something. And I mean, right off the bat, I think it's just a circle. And that is because, like, say we have this length of chicken wire. We could either form it into a circle. That's definitely not the same length. Or we could make a square out of it or something. We could even do a rectangle. Oops, let me do the rectangle over here. But with the rectangle, I already know that compared between a square and a rectangle, a square will always have the most area if these two have the same perimeter. For example, like if we were to compare a 9 by 9 square with a 17 by 1 rectangle, both of these shapes have have a perimeter of 36, but the square is going to have a much bigger area. And that's, I mean, it kind of just makes intuitive sense. So the square will maximize the area. But between a square and a circle, it seems like the circle will be even better because we're basically not wasting any chicken wire on edges, if that makes sense. And I guess what I would do is first calculate the area for a circle and then just double check by calculating the area if the playpen was a square. Oh yeah, Max says he thought it was supposed to be a rectangle. Yeah, generally, like, I guess a lot of the problems are about comparing squares with rectangles, but in this case, we don't have any restriction on what shape it's supposed to be. So I'm going to assume it can be a circle. So let's see, it's 36 meters. So that means the circumference equals 36. Circumference is 2 pi r. So I can solve for the radius as 18 over pi. It's going a bit off. And then from there, the area will be pi r squared, just by the area formula of a circle. So pi r squared equals pi times 18 squared, which is 324. So that's 324 pi. And that's actually, it's almost 1,000, I think. So I can approximate it as 1,000. And so now for the square, wait a second. Did I do something? I think I did something wrong. How is that 1,000? That seems very big. Okay, wait, circumference, 2 pi r equals 36. Oh, okay, yes. R is not 18, R is 18 over pi. Okay. So this is not correct. Basically, my thought process was, it seems like it's around 1,000 square meters, which makes no sense if you have 36 meters of length. So I plugged in R wrong. So R is 18 over pi. And then if we square that, that equals pi times 324 over pi squared. Okay, so this looks a lot more correct. So this area would be 324 over pi. And just like for the sake of, yeah, I wrote 18 over pi on the right side. So that is where my mistake came from. And if the playpen were a square, we know that it would have side length 9 because 36 over 4 equals 9. And then the area would be 9 squared or 81. And that's definitely smaller than 324 over pi because 81 times 3 is less than 324. And I mean, 3 is like a pretty good approximation. So I'm going to go with 324 over pi as the answer.
Yes, I think it is correct. Yay. Yeah, that's an interesting problem. I think I would have probably made a mistake and done the square.
Okay. It's kind of tricky. It's like, generally, I mean, as I said before, generally it's like the constraint is built in that it's square rectangular. So yeah.
Yes. Okay, next problem. Individual number 13. So Walter is boating up and down a certain stretch of river. When he goes downstream, it takes him 30 minutes to cover the stretch of river. Assuming he travels at a constant speed, if Walter's boating speed is 4 times that of the current, how long will it take him to boat the same distance upstream? Oh, wow. Okay. So a lot to unpack here, I think. So there's a river, and when he's going, we can assume there's a current to the river. Oh, Bumbling Bamboo Tree says this is like the AB problem everyone seemed to hate.
Oh no, I remember, that is true. Except this time, at least you're not crossing a river while the current is like pushing you a different way.
You're just like going up and down. Yes, that does make it better. All right. So when he goes downstream, okay, yeah. Also, we can assume, I guess, there's a current in the river. So we'll just say the current is. Does the current go upstream or downstream? I think it goes downstream.
I think. Yep. Good question, though.
Okay. Yeah. So we'll say the current is going downstream. So when he goes downstream, it takes him 30 minutes to cover the stretch of the river. So I think I'm gonna go with the rate times time equals distance formula. So we can say Walter's boating speed is W. Oh, I think it's glitching a little bit. Okay, there we go. Okay, And then, so his rate would be W plus the stream rate, which we'll say is S, because he's going at a constant speed, but then also being pushed by the water. So that would be his rate. And then the time would be 30 minutes. We can just use minutes here because hopefully, yeah, I'm not sure if the answer should be in hours or not, but we'll just say 30 minutes equals the length of the river. Lots of letters so far. I'm a little scared. Okay, and then assuming that he travels at a constant speed, so this will be W, we said before. If Walter's boating speed is 4 times that of the current, how long will it take him to boat the same distance upstream? Oh, okay, so his boating speed is 4 times that of the current. So W is 4 times that of the current S. So we can already replace the letters here. Let's just do W. So W is equal to 4S. So our formula over here, we can replace W with 4S. So 4S plus S becomes 5S. So we can just say 5S times 30 equals the length of the river. So then 5 times 30 is 150. So 150S equals the river. All right, interesting. Okay. And then the question is, how long will it take him to boat the same distance upstream? Okay, so I'm gonna switch colors for fun. But okay, so if he's going upstream, then he'll be going against the current. So his speed will be W minus the current. So we already replaced W with S. So we can just W minus the current times like what we want to find. The time it takes him to boat upstream equals the river. So we can replace W with 4S again. So this will be 4S minus S. So 3T equals R. And we want to know what T is. Oh no, 3ST, sorry. Let me fix this. So W minus S, you can replace it with 4S, so it becomes 3S times T equals R. And we want to know what T is. But the thing is, we have a formula from up here that we know is true, that 150S equals R. So I would just set them equal to each other since R, yeah, 150S, I'll write up here. I don't think you can see this. Give me a second. Okay, there we go. 150S equals R, which also equals 3ST from down here. Okay, so then if we divide by S on both sides, we get 150 equals 3T, or T equals 50. Okay, that was kind of rough. But basically what I did was I used the rate times time equals distance equation. And then I wrote an equation and came to 150S equals R from his like 30 minutes to cover the stretch of the river downstream part. And then I kind of wrote an equation of what we want to define, which was what it would be downstream. And then from those two equations, you can find out what T is.
Cool. Yeah, I really like how methodical that was. And I think it's really cool that a lot of the variables canceled out at the end. So that kind of implies that they were placeholder variables. It didn't really matter what they were. I guess, I don't know. I definitely like how Maggie went through all of the steps. So I feel like that's really good if you are not sure where to start. But if you wanted to think about it maybe like a little more intuitively, I would say like the boat goes at speed C or something. And then we also know that the current, the current goes at speed C and the boat goes at speed 4C because we know that his speed is 4 times of the current. So with the current going downstream, wow, so windy. Okay, going downstream, he goes at a rate of 5C because the speeds add. But going upstream, he goes at a rate of 3C. And in this case, the speeds subtract because he's essentially pushing against the current. And that's definitely similar to what Maggie did because she had like 4S plus S and 4S minus S. So it's essentially the same thing. But from there, we know that going downstream, it took him 30 minutes. I'll just put a little 30 over here. And going upstream, it would make sense that he takes longer. So if I would find like the ratio of the downstream and upstream rates, that is 5C over 3C, or 5/3. And so here I would want to multiply it by 5/3. So the upstream time would be 30 times 5/3, which is 50. And I multiplied by 5/3 because I wanted a bigger answer. So I guess that's just like another way to approach it. It's maybe not as clear as Maggie's, but it could potentially be a little quicker if you're short on time.
Oh yeah, I like that how you phrased it too, but that makes sense. And it's much quicker.
But I mean, better safe than sorry. So like your way definitely gets the right answer. Okay. Okay, so now we have a relay problem. A triangle is inscribed in a circle of radius 10. Ooh, it's geometry, yay. If the longest side of the triangle is 20 and one of its angles is 60 degrees, then what is the length of the shortest side of the triangle? Okay, this is really interesting. So first of all, I'm going to draw the circle, and we know that it has a radius of 10. And that means it has a diameter of 20. And the diameter is basically like the longest length that you can fit inside the circle. For example, like if I drew other lines, any other line would be smaller than 20. So I know that the triangle has to have a side length that is a diameter, because that's the only possible chord that would have length 20. And because of that, I actually know that the triangle is going to be right, no matter how I draw it. For example, if this were the triangle, if this were the triangle, you can, well, okay, my drawing skills are not very good, but you can kind of see that no matter how you position the triangle, it's going to have an angle of 90 degrees. Oh, wait, I've been disconnected. Uh-oh. Okay, I'm back, I think.
Yes.
Cool, that was scary. Anyway, so we know it's going to be a right triangle. And it also says that one of its angles is 60 degrees. So this actually means that it's a very special triangle. So we have the right angle here, we have 60 degrees over here, and we have 30 degrees over here. And that's a very special triangle because it's a 30, 60, 90 triangle, which we know a lot about. And for example, like you can just get a 30, 60, 90, you can just get a 30, 60, 90 triangle by taking an equilateral triangle and dropping an altitude. So this would be a 30, 60, 90 triangle. And we also know a lot about the lengths of a 30, 60, 90 triangle. So if this hypotenuse over here has length 2s, well, this altitude kind of splits this length into two. So the length of the first leg of the triangle would be s. And then we can basically use the Pythagorean theorem to find that the length of the final leg is s squared of 3. Or just in general, like knowing that a 30, 60, 90 triangle has side lengths s, 2s, and s root 3 is super helpful. Oh, yeah, that's a great question, Grace. She asked, how do we know that one side is the diameter? And that is because we know that the triangle has a side length of 20. So basically, like we're trying to, because the triangle is inscribed in this circle, we're trying to find 2 points on the triangle, or sorry, 2 points on the circle, where if we draw the line, the distance is 20. Oh, you got it? Okay, cool. But basically what I was just going to say is that the only way to get 20 is if it's a diameter, because the diameter is of length 20 and it's the longest possible chord that can fit inside the circle. All right, so going back to the problem, let's see, what does it ask? It asks for the length of the shortest side. So that would be this side over here that borders the 60 degrees. Oh yeah, and that would just be 20 over 2, which is 10, because in this case we have 2s equals 20, and then therefore s must equal 10. So I think the answer should be 10. Yeah, it's 10.
That was a really good example with the equilateral triangle. I think that makes a lot of sense. And you can always reference back to the equilateral triangle if you forget the 30, 60, 90 thing. So that's really useful as well.
For sure, yeah.
All right, on to the next problem, which is team number 6. So Nicole, Megan, Anna, Susan, and Darlene are playing a game of Mario Kart. After 8 races, they discuss their placings, not including any computer players. Darlene remarks, the only person I beat was Nicole. Megan replies, I beat Susan, but I lost to Anna. What place did Anna get? Okay, this is fun. Bumbly Bamboo Tree says Darlene seems kind of sour, which is funny. Okay, so we know that Darlene only beat Nicole. So I'm assuming they're like ranked in a number order. So they would probably be the last two because Darlene's like second to last and then Nicole's last. Poor Nicole. So I'll put Darlene second to last and Nicole last. This is like the leaderboard if they're this one. And then Megan replies, I beat Susan, but I lost to Anna. So I think we can assume that Megan, Susan, and Anna. So we got Nicole, and we got Darlene. And then these Megan, Anna, and Susan are all above them. So Megan beat Susan, but lost to Anna. So I'm going to assume Megan's in the middle, I think. Megan beat Susan. Susan. And then she lost to Anna. So Anna must be on the top. Okay, that's good. We have the leaderboard. And then the question is, what place did Anna get? So I think first. Let's see if that's right. Yes, it is.
Nice. Congrats to Anna.
Yes, good job. Poor Nicole for being last.
Yeah. Okay. Now we have Integirls team number 9. There exists a set of positive integers s such that the sum of each of its values digits in base 5 squared equals the sum of its digits in base 7. What is the smallest value in s greater than 1? Okay, so like basically it's saying that maybe s equals 1, 5, 7, 8, or whatever. Probably not these numbers. And of that set, all of them, let's see. Okay, I'm gonna actually do an example. Let's take the number 8. So the sum of each of its values digits in base 5 squared. So first I'm going to write 8 in base 5. So basically like the way I would do that is write it as 13, because in base 5, to calculate the value of 13 base 5, you take 3 times 1, and then you add it to 1 times 5. So that's just like how you denote things in different bases. So 8 in base 10 is equal to 13 in base 5. And okay, I'm assuming that we square the digits and then sum them. So that would give us a sum of 1 squared plus 3 squared equals 10. All right, and then the second part of the problem says the sum of its digits in base 7. So this time we want to write 8 in base 7. And so that equals 11 in base 7. And that's because, again, we multiply this value by 1, and then we add it to this value times 7. So 7 plus 1 equals 8. And now in this case, we only need to add the digits. So 1 plus 1 equals 2. So clearly the answer, oh, sorry, I went off the screen again. Clearly the answer isn't 8, but I just tried 8 as an example to kind of understand what they're getting at. Oh, this is another one that asks for like the smallest value or the largest value. There's a lot of minimization problems here, but because they're asking for the smallest value, I think I'm going to split into cases. So first I'm going to consider the numbers from 2 to 5. Wait, no, from 2 to 4. And then the numbers from, wait, would that be the best way? I'm trying to think.
I think so.
Okay,
yeah.
maybe, yeah.
We could try
So basically, I could try. Basically, I'm splitting them up based on the constraints of base 5 and base 7, because 2 to 4, all of these numbers are just 1 digit in base 5. But here at 5, we start going to 1, 0. So maybe that'll change something. And so 5 and 6 are both something, and then I'll just say 7 on, because here at 7, we start changing with regards to base 7, because all of these numbers we can write as just their own digit in base 7, but with 7 that equals 1 0. And honestly, like, I know none of these are going to work because, well, written in base 5 and base 7, nothing actually changes. So for example, 3 in base 10 equals 3 in base 5, which equals 3 in base 7. And this is not good because it wants the sum of the squares here, which is 9, and the square over here. Sorry, and just the digit itself here, which is 3. So in no case will like x squared equals x for some x that isn't 1. So I know that our answer will not be from 2 to 4. From 5 to 6, written in base 7, actually, yeah, let me just make a little table here. We can try 5 first. So 5 written in base 5 is 1 0 base 5. 6 written in base 5 is 1 1 base 5. And then in base 7, the numbers just stay the same once again because they're less than 7. And so 5 definitely does not work because 1 squared plus 0 squared does not equal 5, hopefully. And 6 also doesn't work because 1 squared plus 1 squared is also not 6. So none of these work. Let me just like write. Okay, I'm actually going to clear off my board now. So now we just have the numbers from 7 on. I'm hoping it's a small answer. It should be a small answer because we're squaring. So if like the numbers get too big, the difference between the two values would be too big. So that's why I'm just like going through and bashing everything. Okay, so I'm going to actually make a table just to make things a little more efficient. So I'm writing each number in both base 5 and base 7. So 7 in base 5 is just 1 1 because it equals, whoa, no, 1 2 because it equals, yes, thank you, because it equals 5 plus 2. And then 8 is 1 3, 9 is 1 4, 10 is 1 5. Let me like add 11. 11 is 1 6. No, well, no, okay, there's no 6 in base 5. So 11 would be 2 0. So I added 11 because that's where the base 5 kind of switches over into a new pattern. And then for base 7, 7 would just be 1 0, 1 1, 1 2, 1 3, 1 4. And it's pretty fast because we can just essentially count up from the first number as long as we're not using forbidden digits. And so now we just have to check to see if we square the digits of this. So for example, that would be 1 squared plus 2 squared equals 5. And that does not equal 1 plus 0. So 7 is not correct. As for 8, 1 squared plus 3 squared equals 10, which does not equal 1 plus 1. So that's also wrong. For 9, it's going to be 1 plus 16, which is definitely not equal to 1 plus 2. For 10, we have 1 plus 25, which is not equal to 1 plus 3.
Oh, wait. I think Kevin said something in the chat, which might be useful.
I think 10 in base 5. Oh, yes, you're right. Sorry. Okay, I definitely made a mistake earlier on. So this would be 20, and then this would be 21, because we can't use the digit 5 in base 5. Thank you, Kevin. Okay, so redoing this 20, we have 2. Oh yeah, this actually works because 2 squared plus 0 squared equals 4, and 1 plus 3 equals 4. So the answer should be 10. Yeah, it is 10. I'm curious if any of you guys had a faster way or a more clever way of doing that. Oh, I see Grace said so too. Because in this case, the bashing worked because it was a small number, but I feel like there should be a clever way of doing it, but I can't think of what. Maybe like, I don't know, do you know, Maggie?
I'm not sure. I think I would have done the same thing as you, just like go through all of them.
Yeah. Interesting. Okay. Should we maybe move on then? But if you guys have like other ideas about this problem, feel free to put it into the chat because now I'm curious.
Yeah. I think Oliver, or I'm not sure if that's how you pronounce your name, but answer should be greater than 7. which does help a little bit because then you'll only have to try like 3 numbers until you get the answer.
That's true, yeah.
All right. Yeah, that was an interesting problem. This next one is individual number 16. So what is the remainder when 5 to the 3rd plus 5 to the 6th plus 5 to the 9 all the way to 5 to the 2022 is divided by 26 squared minus 24 squared? Oh, okay. So this is obviously like super, super large, but you can definitely find a pattern with it. So first, I might find out what this number is first. So 26 squared minus 24 squared kind of follows or reminds me of like x squared minus y squared, which I factored into x minus y times x plus y. And that's like if you distribute x minus y times x plus y, you can see that this is equal. Anyway, so if we did this, then this would equal to 26 minus 24 times 26 plus 24. But you can also calculate these two and then subtract them. But I think this might be a little like shortcut since this becomes 2. So this and then this is 50. Okay, so this is actually not too bad because 2 times 50 is 100. So it's just asking us what's the remainder of this big thing divided by 100. All right. So, okay, so maybe we can see if there's like a pattern in any of the things. So we can start with 5 over here because a lot of the times it does repeat. So 5 is just 5. 5 squared is 25. 5 to the 3rd is 125, but since we're taking it mod 100, then it just becomes 25 because the remainder is 25. 5 to the 4th power, let's see, I think that's, actually I'll do the math just to make sure. So 125 is 5 to the 3rd, I just kind of knew that off the top of my head, but if you multiply by 5 again, it becomes 625. So the remainder is also 25. Okay, interesting. And then we take this and we multiply by 5 again. And something interesting that you'll notice is that if we take this, this becomes 5 and this is 2. And then it's 25 again. And then whatever is left on the right side doesn't really matter. Since we're taking it, the remainder divided by 100, all of this is divisible by. It's like something plus 100. And so I guess we know that like 5 to the whatever power, after like the first 5 to the 1 power, the remainder divided by 100 is always 25. So that's actually pretty cool. So then we can see here, so 5 to the 3rd has the remainder of 25. So all of these also have remainders of 25. So let's see, 25 plus, and it keeps on going. Okay, so I know, yes, Crackling Cherry says dividing by 100 is like looking for the last 2 digits, and that's true because, yeah, dividing by 100 and finding the remainder, just the last 2 digits. Anyways, so over here, we know that 25 times 4, like 25 plus 25 plus 25 plus 25, this equals 100 actually. So we can cancel out like a lot of the sum up here because a lot of it just equals 100. So it won't leave a remainder. So let's just see how many like 5 to the whatevers there are. So it starts from 3, then it goes to 6, 9, and 12. Okay, it goes all the way to 2022. So we can find the difference between them. This is definitely not the most efficient way, but this is how I always do it. So the difference between these two is 2019. And then the difference between each like term is 3. So I just divide 2019 by 3. So we'll do that on the side here. Okay, so there's 673 like spaces in between here because they're all like divisible by 3. So 673 like little things. And if you see like 369, for example, there's 2 like spaces in between them, but there's 3 terms. So there's like, you have to add 1 to 673 to get the total number of terms in here. So this would be 674 terms in this like big 5 plus all the way over here. And then, so we know that in groups of 4, the remainder is 0. So we can just see like the closest, what's it called? Multiple of 4 closest to 674. Let's do on the bottom. Okay, so let's see. I know we can just do 674 divided by 4. But we also know that like 600 is divisible by 4, but it's fine. So 27. Okay, so if we divide by 4, there's 2 left over. And so that means there's like 4 groups of 4, 4 groups of 4, 4 groups of 4, and then there's 2 terms left over. So that would be 5 to the 2021 and then 5 to the 2022. So we can just add the remainders of these two to get the answer. So it would be 25, and then this is also 25. So the remainder is 50. That's kind of messy, but I think the general idea makes sense, hopefully.
Yeah, and the answer is 50 again. Yeah, I really like that problem. I think it kind of just centers on, first of all, recognizing difference of squares. So definitely whenever you see like a squared minus b squared, yeah, exactly. Big numbers in the problems seem intimidating, but most of the time they're hidden patterns, as Cindy said. Like we definitely didn't calculate any gigantic powers of 5 as you would expect. Yeah, but generally just looking for things in the form a squared minus b squared, or even like products of a times b where a and b are differing by an even number, that's really helpful. Cool. So now on to individual number 15. Julie rolls 5 fair tetrahedral dice labeled with 1, 2, 3, and 4. If the probability that the sum of the top numbers on the 5 dice is at least 18. Oh, okay. So what is the probability? And express your answer as a fraction, then add the numerator and denominator. Another one where we get a fraction answer, but we actually want a plus b. Okay, so to get a sum that's at least 18, first of all, I know we have to have at least 1 4, because if we didn't have 4, the biggest we could get is just 3, 3, 3, 3. And that's 12, which is too small. Yep, and the max sum, as Crackling Cherry says, is 20, because that's when we get 4 plus 4 plus 4 plus 4. And honestly, 20 is super close to 18, so that's good news because it means we won't have to go through many cases. So I'm just going to do case sort based on the number of 4s. So we know there has to either be 1 4, 2 4, 3 4s, or 4 4s. 4 4s. Yeah. Again, just because like it's impossible to have 0 4s. Actually, is it even possible to have 1 4? No, it's not, because if we only have 1 4, then even if the other 3 are the biggest that they can be, which is 3, this will sum to 13, and that is a lot less than 18. So let's see if I can like eliminate some more. For 2 4s, 4 4 3 3, 8 11 14. So yeah, this, oh shoot, I'm off the page again. Okay. If I have 2 4s, they're going to sum to 14. And again, that's less than 18. So this case is also just impossible. And if we had 3 4s, oh wow, wait a second. Oh wait, okay, I'm kind of stupid. There are 5 dice, not 4 dice. So let's try that again. I'm going to rewrite down 1 4 2 4 3 4s, 4 4s, and now we can actually have 5 4s. So let's see if any of the numbers change. So if we had 1 4, let's again fill in 4 3s over here. So that gives us a sum of 16. So that's still too small. So again, this case will be impossible. Now let's try 4 4 and then 3 3 3. And if you notice, we're basically just replacing a 3 with a 4. So I don't need to add it up again. I know it's going to be 1 bigger, which is 17. So again, this is wrong. And if there were 3 4s, if we make the other 3s, then it will sum to 18. So that's just right. So 4 4 4 3 3 is the only way that we can have 3 4s. If we had 4 4s, it's a lot of 4s. We could have either a 3 or a 2. and that is because this would sum to 19, and the one below it would sum to 18. And then finally, if we have 5 fours, there's just one way of doing that. So actually, because the number 18 is super close to 20, which is the maximum that we can reach with these set of dies, the answer doesn't involve that much casework. So we only really have 4 possible cases. And so now the way I'll do this is for 4, 4, 4, 3, 3, there are 5 choose 2, or that would be 10. There are 10 ways to place these 2 3s. So for example, we could have rolled a 4 on one die, and then a 4, and then a 4, and then a 3, and then a 3. Or we could have done 4, 4, 3, 4, 3. And so on and so forth. So there are 10 of these. And basically, I'm just counting this, how many strings of 4s and 3s are possible. So similarly, with 4 4s and 1 3, well, there's actually only 5 ways to rearrange this, because there's 5 places where the 3 could go. Similarly, there's 5 places for where the 2 could go over here. It's just the exact same logic. And then actually for 5 4s, there's only one way to do this, which is just that, because all the numbers are the same. And now, because it's a probability, we'll want to divide by the total number of, well, I guess combinations. So it really helps to think about like what exactly we were counting. In this case, I chose to count 5 number strings of numbers. So how would I construct just any string of 5 numbers where the 5 numbers are either 1, 2, 3, or 4? Well, there's 4 choices for the first. There's 4 choices for the second slot. There's 4 choices for the third, and there's 4 choices for the fourth. So it's, oh, I keep thinking that there are 4 slots. No, there are 5 slots. So the denominator would just be 4 to the 5th. And so all I need to do is simplify this fraction. I'm going to do this on the left side. So 5 choose 2 is 10. 10 plus 5 is 15, plus 5 is 20. So the numerator here is 21. And as for 4 to the 5th, I don't actually know that off the top of my head, but I know that it equals 2 squared to the 5th, which equals 2 to the 10th, which I know is 1,024. So overall, the answer should be 21 over 1,024. And once again, we need to make sure to answer the question. So it asks us for the sum of the numerator and the denominator. So that would be 1,045, I believe. That was also like a bit of a messy problem, but I think just keeping your work organized should be helpful in not missing a case or anything. Oh yeah, okay, it is 1,045.
Ah, amazing. And we only went through minutes over time, so that's good.
Oh wait, we did. I didn't notice. Okay, nice.
But yeah, thank you guys for coming to the live solve. Like Michelle said at the beginning, if you are interested in starting your own integrals chapter or maybe competing in one of the competitions, it'll be good to like check out the ones locally. If you don't have a chapter locally, you can also like, I think you can join other chapters. So yeah, just check out Integrals, they're pretty cool. And check out our classes too for the daily challenge.
Yep. Thanks for coming.
Bye everyone.
Bye. I love these anonymous names in the chat. We have Crackling Cherry and Bumbling Bamboo Tree.
Yeah,
Yeah.
they're both very good.
Bye guys.